So, we are now moving into the final part of the course, which focuses on water resources management. And which is, in a way, the most applied part of my lectures. And we will focus in particular on how to make decisions regarding the management of water. Basically, in the first part of the course, we have focused on the estimation of water resources availability, which is an important prerequisite in order to be able to take decisions then on the allocation of water. And now we focus on decisions. And we should always keep in mind that usually a water resources management problem arises because there is not enough water to satisfy all the requests, all the demands. So basically when we work and we are called to provide a consultancy activity, to provide suggestions on a water resources management problem, we are always in a situation in which there are more demands than availability of water resources. Basically, people realize that they are suffering a situation of water scarcity. They don't realize how much water they have at disposal. They don't realize how to improve the situation. They have some ideas, but basically they call us because they want the technical advice in order to improve the situation. But the fact is that they are suffering from a situation of water scarcity. And very often the situation of water scarcity, at least in our regions, is caused by water demands, excessive water demands for irrigation. In our region, usually we don't have to really face problems of lack of water for civil use. You know that the civil use is as a priority, and therefore, usually in our regions we have enough water to satisfy the civil needs. The problem is irrigation. So, how should we take these decisions? These are important decisions anyway, because even if, in a way, irrigation is not as important, the water used for irrigation is not as important, as strictly important as the water need for civil use. But in any case, you have to think that irrigation means agriculture, and agriculture means water for food. So, even if it's not really a situation that is much concerning from a social point of view, let's say that is not the most concerning one that we could face, still, it's a situation that can be concerning for economical reasons, for reasons that in a way make the people much concerned. Anyway, so basically, what are the principles, the basic principles, as you see in the title of the slide, that can guide us to take this decision, which is a decision that, by necessity, will leave somebody not really happy. So, what are the basic principles, again, that we should consult while taking a decision? And beyond that, how can we take a decision, and what is the technically efficient way of taking a decision, and what is the most convenient way of taking a decision with respect to people? These are the questions that we have to answer to. When we speak about basic principles of water resources management, of course there is a long literature on this. There is a lot of information, even on the web, that you may consult. And there are different principles that can be invoked. And you know that water resources management is a young discipline, and therefore it was a matter of the past 30 years to try to identify what are the principles that one should follow. For instance, a unanimously accepted principle is that water for civil use, the civil use has a priority. But there are, of course, many other principles that we should stick on. So the first question is, what are these principles? And there was 20 years ago, I think I already mentioned to you this conference, a very important conference in Dublin, which tried to elaborate some basic principles for water resources management. This is almost like philosophy. This is a kind of ethical guidance that we have to look for at the beginning, to try to understand what is really admissible, what is ethical, and what is not. For instance, one may wonder, what if I increase the price for water? Is this an ethical decision or not? Should I give the water to the person who is willing to pay, or should I give the priority to persons that have no money to pay? Of course, this is an example of an ethical principle. So should we grant the water to people who can pay for that, or we should not really consider money as a criteria for taking the decision? One would say, okay, it's better not to consider money. But on the other hand, you have to think that securing water, providing water to people, costs money. So, in a way, you need money to provide water to people. And if you don't care about money, if you don't give the priority to people who are willing to pay, then you may end up in a situation where you have no means to provide water to people. And therefore, you know, it's not an easy decision. And another decision is, should be water a public good or not? Should be considered as a public good or not? You know that in Italy we had a vote recently on the opportunity that the water is managed by private companies rather than public administration. So these are all questions that we should look for. So we should identify the principles. And then, as I said 20 years ago in this conference, which was an international conference, people got together and tried to set up some basic principles. And the principles that you can see here, I think we already mentioned them. And they are very basic. And just to remind you, the principles, the Dublin principles, who are considered the basis for modern water resources management, state that water is finite, vulnerable, and is essential. And water is finite, I already mentioned to you, it's not so, it seems to be a trivial concept, but it's not so trivial, because before that, people were used to consider water as an infinite good. And now we have to realize that water is finite. And then water resources development and management should be based on a participatory approach, we already mentioned this, which states that we should always involve people when taking decisions, and then women play a central role, which it's a bit amazing, but indeed it's a principle that is unanimously recognized as very important. And it's also a principle that tends to make sure that the gender balance is respected when taking decisions, and in particular decisions about water. And also water as an economic value. And this was a very important principle introduced at that time. If you accept that water is finite, then you have to accept that water has an economic value. And you have to accept that people pay for it. And of course you can establish different regulations for paying. You can make sure that a minimal amount of water is anyway guaranteed to people, but the fact that water is an economic value now, it's a principle that is unanimously accepted. For comparison, you may think to another vital and essential element like the air. The air is not recognized so far to have an economical value. But if you think to your necessity to live, they are comparable. You need air, more or less, as long as you need, as much as you need water. Of course, without water you can survive a bit more than without air, but they are really comparable. They are natural elements. They are basically available everywhere. Maybe that for air you can say that it's not so costly to sell air to people, but it's costly to make sure that the air is clean. So they are very comparable. So for water we reach at the conclusion that it has an economical value and people should pay for it. I'm not saying that we should do the same for air. I don't know this. I'm just noticing that it was this principle was really very debated and very controversial, like if we had today to discuss on the economic value way, and maybe that in the future we will need to introduce a taxation on our air, on the air that we breathe. Who knows? But in any case, let's focus on water. And also there are other principles, more, let's say, more technical, more practical for water resources management. And I just want to provide you some examples, and you can find in the web a lot of examples, and I think these are particularly significant. For instance, the principle related to sovereignty, which says that states can dispose of their resources without damaging other states. And this is a very important principle when we talk of transboundary water management, which means that the water management has to be agreed between different countries. This requires setting up international laws. And this is really very debated today. And I give you an example, because transboundary water resources management is not a so frequent problem in Europe. It's more a problem of African countries, like the River Nile example, or the example of the Jordan River, which dictates draws the divide between Israel and Jordan. And you know, they had wars for managing the water of big rivers. And think, for instance, the Nile River example, where now in Ethiopia they are building a huge dam. And of course, if they build a dam, why they build a dam? They build a dam in order to be able to use the water of the Nile River. But of course, if they use the water, which is a right of the Ethiopians, then there is less water available downstream, and therefore there is the risk of wars. And an European example, an Italian example, is the management of the Lake Maggiore, the Lago Maggiore, which is a regulated lake, meaning that the level of the lake is regulated, and basically is regulated because it's an Italian need to keep the storage in the lake higher during summer, in order to be able to use the water for irrigation. But on the other hand, the northern part of the Lake Maggiore is in Switzerland, and they get the risk to get flooded if the level of the lake is much higher than normal. And they don't profit from water for irrigation from the Lake Maggiore because they are upstream. So basically, the management of the Lake Maggiore was the subject of an international treaty among Italy and Switzerland to set up rules that were agreed by the two countries in order to safeguard Switzerland from flood risk and to secure water for irrigation in Italy. Another principle is related to the use of resources. There are a lot of principles that provide a discipline for the use of water with the aim to make sure that the environment is protected. For instance, you see here mentioned the environmental flow, but there are also other principles in the use of groundwater, which are principles that are basically agreed, which state that we shouldn't provoke an overexploitation of groundwater, because of course if we take from the underground water that is very old, it means that we may not give enough time to the aquifer to recover from our withdrawal. And also principles related to the environment in general, these are similar. Principles related to organization and procedures, transparency, decision-taking, low level of hierarchy, etc. And principles related to, again, transboundary water resources management. What does it mean that these are principles? It means that they are like ethical advices that are basically agreed by international organization and by international bodies like the United Nations, like UNESCO, and these are suggestions. Suggestions that states, individual states, may convert in laws. So, of course, when you have to deal with the water resources management problem, the first thing that you have to do is to consult the laws of the country where you operate. And for instance, in Italy, there is the testo unico in materia di acque, which is the unique law regarding water, which was issued in 2006, which is the basic reference for everything is related to the management of water. And then, if you consult this law, you will see that some regulations are demanded, are delegated to the regions, whose regions has to develop the individual water resources management plan. This is compulsory by law. Any region in Italy should have adopted, at least many of them should have adopted the water resources management plan. It's called Piano di tutela delle acque. Literal translation would be plan for the preservation of water resources. And therefore, you have to look at the laws, and you will see that in many cases you don't find enough guidance to solve water resources management problems, and then you may take inspiration from the principles. I'm not dedicating more time on principles because this is not really a technical issue. It's just to tell you that there are agreed principles by international organizations on the management of water, and then there are restrictions by law at the level of individual states, or maybe also international treaties like Switzerland and Italy that you have to respect. And one thing you should consider that getting oriented in the laws regarding water is not easy. So the indications that I provided to you, which are look at the testo unico in materia di acque, look at the regional plan for water resources protection, these are just two very general indications, because when you go at the local level, you will find that there are bodies governing waters with different tasks who can issue their own laws. Like, if you think at the hydrogeological risk and mitigation of the flood risk, we have bodies in Italy who are in charge of taking care of the most important river basins. They are called river basin authorities, and they have the capacity of issuing laws for what regards the mitigation of flood risk. So, for instance, the River Basin Authority of the Po River Basin Authority, has issued some laws regarding the design of bridges that cross the Po River and its main tributaries. Then there are the consortiums for irrigation, Consorzio Bonifica, which in Italy are also reclamation consortium. Reclamation means basically the drainage of the lowlands of the flat areas, while irrigation is not what it means. And in Italy we have the same body which takes care of reclamation and irrigation. And they also have some laws, meaning that if you want, for instance, to build a house on the portion of land that is under the competence of the consortium, they can ask you to pay taxes, and they can give you some prescriptions for the treatment of the rainwater. Because if they feel that by building your house you decrease the permeability of the soil, and therefore you increase the flood flows, then they can give you some prescriptions. So getting oriented in this mix of laws, in this network of laws, is not easy. And usually this is one of the most difficult tasks, at least in Italy, when dealing with water resources management. And the reason why is there are so many laws, is that in Italy there is a lot of fragmentation in the management of water. So we have on one end, as I said, the consortium for reclamation for managing irrigation, and then we have the River Basin Authority for managing the flood risk. And the reason for that, the reason of this fragmentation is that Italy was set up as a unified country just 150 years ago, which is a time span that for managing water is nothing. Because we started managing water 2,000 years ago, And therefore, for instance, the consortium for irrigation was set up 500 years ago, and therefore, you know, there is still a lot of fragmentation. Italy is a quite complicated country from this point of view. Now, what is water resources management? From a technical point of view, let's say, first of all, that today we use this word integrated, which means that when you plan the use of water, you should consider water as a whole. You shouldn't separate different uses, and you shouldn't separate different problems. For instance, irrigation cannot be separated by the drainage, and cannot be separated by water from water sanitation. Water sanitation means that when you get dirty water from the cities, you try to clean it. Because if you separate irrigation from sanitation, you lose, for instance, the opportunity to use, to reuse water for irrigation. Because of course, when you clean the water, you get water that from the water sanitation plant, you get water which is not good to drink, but could be useful for irrigation. And therefore, this word integrated was introduced in the Dublin Conference to mean that we should treat all the problems related to water as a whole. We should deal with water. And this would also help to overcome the problem of fragmentation. Now, from a technical point of view, what are we asked to do? If you look at water resources management problem, I tried to identify some common features in order to provide some guidance, because you know, it's not easy to give technical guidance to solve a water resources management problem, because these problems are very much diverse. And therefore it's difficult to find some unique principles, some general guiding principles. And I try to identify some common features of this water resources management problem. First of all, as I said, a common feature is that usually you don't have enough water to satisfy everybody. And therefore, what you should first do is to assess how much water is available. And we dedicated the first part of this course to this problem, to solving this problem. So you can look at the data, and if you don't have data, then you may consider rainfall runoff modeling, or, as we have seen, stochastic simulation. This is the first problem that you have to solve. So first, how much water do we have? And one thing that you should consider is that getting data is not easy. For many reasons. Sometimes you have to pay for that. Sometimes you have to, by hand, putting the data into the computer, because the data are in paper form and not in digital form. And sometimes, you know, you have, not sometimes, always, you have different bodies collecting data. For instance, in Italy, we have the National Hydrology Service that now is managed by the Agency for Environmental Protection, which operates at the level of each single region. But then you have the public body for hydropower production, Enel, which also collects water. You have the Reclamation Consortium that collect data. So you have different bodies collecting data, and there is no systematization of this data. And now, for instance, the European Union is investing a lot of money to promote systematization of this data, meaning that all the data related, for instance, to water should be collected in a unique place and made accessible to the population. But this is an ongoing process. So, in any case, this step, quantification of water availability, is a difficult step for you, in any case. And And then, once water availability is known, then the subsequent fundamental step is the estimation of water demands, which is basically an easier task with respect to the estimation of water resources availability. But still, this task requires an assessment of socio-economic conditions, and requires making some prediction on the future, requires getting some information on climate change, etc. So it's not a very easy task. And the focus is in our regions to be concentrated on irrigation demands, because these are the most relevant. I already showed you what is the proportion of water demand for irrigation with respect to the global water demands, and they are about 70% of the total. So irrigation is really, and it's really very important. So you need a social analysis, and of course the literature helps you in quantifying the water demands. For irrigation, for instance, you have a lot of guidance on crop water requirements, and you have also a lot of guidance, and I think that you took some courses already on this, on the water demand for city use. So you know that a city like Bologna needs water in an amount of water which is about, for each person, 400 liters per day, which is a bit amazing, but you should consider that this demand is not, strictly speaking, the individual demand of water, is the global demand of water divided by the number of people. So it also takes into account the demands for water for industrial use, for irrigation, etc. Then you have to estimate the water losses, which is, from a practical point of view, is really a challenge. Because water losses are there, they are very significant. We are talking in Italy of about 30% of water losses in the aqueducts, and in the irrigation networks we are talking about 50% of water losses. So they are really significant, and their estimation is really a challenge. Especially because, you should do everything in a transparent way. So to explain to people that your guess for water losses is about 30%, of course, these people want to see data, not just guesses. And then you have to estimate the potential for other sources of sinkers, like water reuse, etc. And then, what are you required to do in general? Basically, any problem can be reduced to a water balance problem. At the end, once that you quantify water resources availability and water demands, then you have to make a simple water balance. You have to compare availability with demands. Because the first step is to quantify what is the deficit. How much water you need more to satisfy the water needs. And then, the water balance is, at the end, a common feature of any water resources management problem. And it seems very simple, but it's not. It's simple from a conceptual point of view. It's very simple to understand what it means, water balance. But to perform a water balance in practice, it's far from easy. And you see these are the basic steps which are summarized. Water availability, water quality. Water quality may be necessary because, for instance, if you think about getting water from the Po River, you are concerned by the quality, and you are concerned, so you wonder, can I use this water for irrigation? Can I use this water for a kind of second level city use? Second level is not to drink, but just to wash cars, etc. And then you need an estimate of water quality, demands, losses, sink terms, as I said. And then you have to identify, when you talk about a balance of water, you have to identify your control volume, meaning the volume where you apply the balance. And this is also something that is challenging because basically, typically your control volume is the water district for an aqueduct, for instance. But it may be expanded to include connected districts because we are looking today for interconnections among water districts. Because of course, if you get a crisis in a water district, if the water district is connected to another district, then you can solve the crisis through the connection. And also you may include in the water balance the catchment. The catchment from which you get the water to serve the water district. So, availability, demands, water balance applied to a control volume that needs to be identified. And then you are not done, because given that you have a water problem, then you have to take a decision how to solve this problem. But before getting to the decision, let's summarize the critical issues. Groundwater dynamics, this is a problem because so far in my lectures I mainly dealt with river flows. I told you about rainfall modeling, I told you about simulation of river flows. And basically river flows are quite, let's say, easy to simulate because you can see them. Instead, groundwater dynamics is much more difficult to simulate. And water resources management problems almost always involve also water withdrawal from groundwater. This is really something that is delicate. Other examples from my experience, estimation of irrigation efficiency. Because if you know that a given plant requires 2 liters of water during a given day, you need to bring more water. Because not all the water that you bring there goes to the plant. For instance, because you are also irrigating some part of the soil which is not serving the plant. Or because if you think about flood irrigation, I already mentioned to you flood irrigation, you need more water to secure to the soil, more water with respect to what the plant strictly needs. Estimation of water losses, I already mentioned this. Estimation of the future. What happens in the future, climate change or water quality. Some guidelines for computing the water balance. What is the level of detail to which we should make the computation? Level of detail means the time scale. Should I compute the water balance at hourly time scale, daily time scale, monthly time scale? The level of detail means should I consider water resources availability, water demands, by looking at any single contribution, even the less significant ones or not. And level of detail also means the spatial resolution. Should I model the water delivery at any single hours, or should I divide the cities in districts, and then stop at the level of detail of the districts? Now, my recommendation is that the level of detail should be decided based on the available information. If you don't have enough information, you can't provide fine details, even if some people try to do that. So if you want to simulate what happens at the level of any single house. You have to know how many people are living in any single house. Otherwise, if you just know how many people are living in a district, it's better that you stop at the level of the district. And for the time scale, if you want to model water demands and availability at hourly time scale, then you need data at hourly time scale or finite. So don't try to provide more details with respect to what your underlying information can allow you to do. And consider also uncertainty. If you have the data and find a solution, but with a lot of uncertainty, then it's dangerous to try to reproduce fine details. If you have a lot of uncertainty, it's better if you use robust models. Robust, I think I already defined what it means. Robust means a model that is always not very long. And when you get a complex model, basically the complex model is in principle able to provide you a lot of details, but it may also undergo very significant mistakes. If you simplify your model, usually you get a more robust model, meaning that it's not very precise if you look at the details, but on the other hand, it's not very wrong. And sometimes when when a decision is really critical, it's better to stick on a robust approach because it's safer. Maybe that it doesn't give you, it always gives to you an answer that is affected by uncertainty, but this uncertainty is not huge. While a complex model, in principle, is more precise, but it can be, in some instances, affected by a lot of uncertainty. So always consider uncertainty, information and related uncertainty. And keep in mind that uncertainty is an attribute to your information. So information means data and means also indications on their uncertainty.